What's up, good people? It's Entelos once again, and you're getting this done. Now, today is day 2 of how we'll be building the first Kenyan autonomous aircraft. And today we'll talk about the brain, okay? We'll talk how we will be raising this child. Remember, now it's a child now because we will be giving it so much attention. And we will talk about the autonomous part of how we will develop this aircraft, okay? So, first of all, I have, done my research, and we will build this autonomous technology in phases, okay? Remember, we are dealing with an aircraft. So, first of all, we have to factor in the flight dynamics. We will also have to factor in the control theory and the onboard computer architecture, what kind of processors and microcontrollers that we will use, and we'll also finally finish up with the programming language. Now that will be the phase 1, will be just a simple research about this autonomous technology. The second part will be phase 2, and phase 2 will be looking into the sensor integration, and that sensor needs to answer questions like where am I, where is this aircraft supposed to fly, what am I supposed to do at what point in time. So these are the kind of questions that we really need to think as programmers as we are trying to develop this brain that will power our first Kenyan autonomous aircraft, okay? And just to walk you through the kind of sensors that we will be using, these are, they are normal sensors. We'll go into the details once we reach at a level that we will be dealing with them. The first one will be the IMU, okay? The second one will be the GPS. Another useful sensor will be the magnetometer. Another one will be barometer, and another one will be airspeed sensor, just to mention a few. Okay, so those are the sensors that are on top of my head. We will actually look into each one of them on how it will be useful to power the brain of our autonomous aircraft. Okay, now phase 3 will be now the fusion of these sensors and the programs, and we have to now look into uh, uh, outputs like position, the velocity of the aircraft, the altitude, the heading, the pitch, roll, and yaw. We need to look into the details of how these sensors, the input from the sensors, we will actually need to adjust the, you know, this kind of uh, values in order to accurately control our autonomous aircraft. Remember, this aircraft does not have a pilot. It has to make the decision on its own. So that will be phase 3, okay? We will be dealing with variables like position, velocity, altitude, heading, roll, and yaw. For every aeronautical engineer, they have actually interacted with this kind of, data, and we will go even deeper in our future series, okay? Now, another part, another part will be the vertical takeoff and landing. Remember, I am leaning into vertical takeoff and landing because you're trying to avoid, or uh, trying to have to build another airport or runway, because vertical takeoff and landing will be actually be a game changer in most of our scenarios, okay? And I am aware that it will be challenging, so we will actually have to push our creativity and resources to the limit, okay? And some of the questions that we need to ask ourselves is that how will it, decide how to take off vertically? Decisions like hovering so that you can identify the right location to land, cruising, transitioning from vertical takeoff to cruising, and transitioning back from cruising to landing. Okay, as I had shared earlier, remember this aircraft will be a fusion of two, two, two designs. The first one will be the electric part where it will be using motors to take off vertically. Then it will switch to a jet engine, which will also develop, okay, for the cruise, okay. And once it reaches its destination, now it switches back to the electric motors so that it can land vertically. So that one will be phase 5, okay. The other phase that we will actually have to go deeper and do the research and try to practically implement in this brain of our aircraft will be the navigation, okay. And navigation, we have to look into functions like the waypoint, which path will this autonomous aircraft take. Then we also have to integrate with GPS navigation, the flight path, how it can return home in case of an unfortunate scenario that it has to return home, or maybe a mechanical failure, and geofencing so that it cannot go into unauthorized areas, because remember, drones and aircraft are very sensitive, okay. We have to work with authorities, and geofencing will also be a factor to consider, because we also have to be responsible while we are doing this project, okay. And we will also have to uh, technically develop this brain, in that it can plan, it can uh, plan the entire mission. Remember, it's an autonomous aircraft, so we don't have to try to control it in real time, okay. So what we need to do is just like uh, input the takeoff, maybe takeoff time, takeoff location, the flight route, okay, the delivery of the cargo, return and landing, okay. Once that is done, the aircraft is ready to take off and complete its mission. So that will be just the input. From there, the aircraft itself will make those kind of the decisions, okay. Now that is phase 6, okay. Now we also have phase 7, which will be the aircraft's health. Remember, there is no pilot on board while we are developing this aircraft, and we also need to be responsible so that we can know what's going on in our airborne aircraft. So this will bring us to another phase where we will be monitoring the health of that aircraft, okay? And when we look at the health, we need to understand the battery levels of the aircraft so that we can understand whether it can take off vertically or not. What kind of measures do we need to actually even make the takeoffs and landing successful, or different alternatives if those ones fail. Those are questions that an engineer should ask as we are developing this autonomous aircraft, okay. Another thing that we need to monitor as the health of our autonomous aircraft will be the temperature of maybe the engines, the processors, and and any other thing that might be affected by the temperature, okay. And remember, temperature is very dangerous, can actually melt some of the components or even the sensors, and we will not achieve our goal of flying this autonomous aircraft safely, okay. So we have to monitor the temperature. Another thing is the motor health. That one we will have to brainstorm of how we will monitor the health of these motors that will be responsible for the vertical takeoff and landing, okay, and also the sensors and communication. So generally, will be the health of our autonomous aircraft, okay. We need to understand what's going on, and in case of an emergency, okay, in case of a certain eventuality, how do we handle this? Remember, it's our first time, but we also need to have that those kind of thinking at the back of our mind, okay. And another one will be phase 8. The phase 8 will be the computer's vision, okay. And since it's an autonomous aircraft and we have high-speed internet, you can also give the autonomous aircraft eyes where from, let's say, our watchtower or our control tower, you can actually see what the aircraft is seeing in real time and stream maybe the images or the videos in real time as the autonomous aircraft is flying. That will also be an interesting endeavor, but it's not that difficult. You can always integrate the camera hardwares and any other type of a camera. I've actually seen in movies that there are infrared cameras which can see in the dark. That will also be a very interesting endeavor, and we will get into that, okay? And another option that we really look into is the LiDAR. I don't know a lot, but uh, right now, but we'll do research and we will see what can we practically implement in our aircraft, okay? And with this kind of vision, our autonomous aircraft will have capabilities like detecting the landing zones. It will recognize obstacles. It will track objects. It will read markers, and it will land precisely. That's why our autonomous aircraft needs a vision. Okay. Another phase of developing this autonomous aircraft will be, decision making. Okay, decision making like selecting the routes, like which kind of route is safer depending on real-time changes of the scenario. Can also predict weather. Okay, these are things that are common these days with the current technology that we have. Can also avoid birds. Remember, in the sky we have birds that are also flying, and also other aircrafts. Okay, it will also be challenging to introduce, but we will pursue it regardless. Remember, this is an adventure, okay? We're not running a business. We just want to see how far can our ideas go, okay? And finally, how can we optimize the fuel so that we are fuel efficient and we can reach our destination? So that will be phase 9, okay? Another phase will be, you know, the phase 10. Phase 10 will be actually, the fleet intelligence of our autonomous aircraft. Okay. Now, I'm imagining a scenario where we actually have 10 or even 20 autonomous aircraft flying in a particular direction to deliver, you know, certain kind of goods and whatever. Now, in this kind of a scenario, you need an architecture or an infrastructure of how these autonomous aircraft can communicate with each other. Okay, so let's say for example, the first two autonomous aircrafts actually encounter very very strong winds. Okay, this information can be relayed to the other fleet of autonomous aircraft so that maybe they can divert or take a different route, or even saving the other remaining 8 autonomous aircraft in an eventuality where the first two that have actually crashed or something like that. So these are the decisions as this autonomous aircraft is supposed to make, okay? And those kind of communication. So that will be another area that we will pursue it to the end, okay? And lastly, is that we need to monitor this autonomous aircraft, and or even in future we need to monitor the fleet of autonomous aircraft that are actually in the air. Okay, so I'm imagining a scenario where we'll actually have a control room where we are getting real-time data of how this aircraft will be flying. Now, that will actually only be the software part, where we will try to simulate, okay, virtually what is happening in real life so that you can have a clear visual imagination, or uh, visual presentation of what is going on in real time. Okay, so we will try to come up with a way of building our own software that will monitor our autonomous aircraft, or even a fleet of autonomous aircraft. Okay, and phase 12 will be essentially you know carrying out its own test, where it can actually run itself, test by itself. And if there is an issue that needs to be changed or rectified or adjusted or communicated to authority, this autonomous aircraft can communicate by itself. Okay. Remember, we are trying to build an aircraft that can think by itself, because technologically that's where we are as the current world, and we can do it. By the way, it will be very interesting. I know it will be challenging. Some of the things I've actually highlighted, some will be actually very easy, others will be difficult, others will need even some technical expertise. So if you are somebody who is watching and is actually fascinated with this conversation and this topic, you can always share your ideas, your thoughts, your technical know-how. I will gladly take I'll take it and we try to improve, because my mission is to build this autonomous aircraft. Remember, it has never been done before. It has never been done before here in Kenya. We're doing it for the first time. It will be difficult, but the lessons that we will learn will actually be very valuable in our future projects. Okay, those are the 12 phases that we will try to develop this brain technically. I've actually highlighted every kind of angle that we can handle these projects. There might be others that may come in future, okay, but we can always improve and learn from our mistakes and our current level. Okay, I really appreciated your time. See you in the day 3 of trying to build an autonomous aircraft. We'll actually now cover a certain area. Maybe it will be materials or designs. Whichever comes first, we will address it. And then in future, we'll also discuss of how we will get the materials locally to actually build the mainframes. That will be a later video, okay? And we will go into the details later, okay? I really appreciated your time if you have watched so far. Again, it's a very interesting and a challenging endeavor, but mine is to learn as you learn, and I believe you can always achieve amazing things. Once again, St. Talos, and we're getting things done. Huh?